Hi my guys, welcome again. So with me is another calculus using first principle. So we are going to solve y is equal to cos x using first principle. So our aim is to find dy dx dy dx. So let add an increment. So y plus changing y is equal to cos into x plus changing x. Okay, so that is the increment for both x and y. Okay, so from identity we know that cos a plus b is equal to cos a cos b minus sin a sin b from trigonometric identity. Okay, so let's apply this formula for the cos into x plus dx. Okay, so cos x plus dx will be cos x, let here to be a and here b, therefore cos a is cos x plus cos dx cos x cos dx minus sin x and sin dx. Okay, so this is how we derive it. So the equation will be y plus changing y is equal to cos x cos dx minus sin x sin dx, and we can say dy is equal to cos x cos dx minus sin x sin dx minus this y, and y is equal to cos x, but y is equal to cos x from the beginning. Okay, so let's replace y as cos, then dy will be cos x cos dx minus sin x sin dx minus y, but y is cos. Let's rearrange. Dy will be cos x cos dx minus cos, since here we have cos x, so we can just rearrange cos x minus into sin x sin dx. Okay, so dy will be cos out, cos x factor out, remain cos dx minus cos into cos, then here will be minus 1, and then here will be minus sin x sin dx. So let's divided by both sides by cos dx to both sides dx. Okay, so dy dx will be cos x into cos dx minus 1 all over dx minus sin x dot sin dx over dx, but at limit cos dx minus 1 all over dx is equal to 0, and sin dx over dx is equal to 1. So if you substitute, dy over dx will be cos x into 0 minus sine x into 1. Since sine dx over dx will be 1 and cos dx minus 1 over dx will be 0, so here goes will be 0, and dy over dx will be minus sine x. That is the final solution. So for any given cos x, the derivative of cos will be minus sine x. The dy dx of cos will be minus sine x. So that is the final solution. Don't forget to subscribe.